Hello, everyone. First, I'd like to thank the Idaho Wheat Commission for supporting our project on control of wheat strep rust. This project is in cooperation with Dr. Chen, Dr. Yuego Wang, and Dr. Julia Marshall. As you all know, wheat strep rust is one of the most important diseases in the Pacific Northwest. In the last 47 years, strep rust was able to cause from 1% to over 90% year loss. And in last year, we forecast strep rust to cause 33% year loss. That's around the average. In our artificially inactive fields, actually strep rust causes year loss on susceptible varieties over 80% on winter wheat and 50% on spring wheat. In the last 20 years, strep rust actually caused much more potential year loss on susceptible varieties that's reached to 44% on average. And on commercially growing varieties, the average year loss was over the last 20 years is about 8%. So this is still a huge year loss. For Idaho alone, that's about 8 million bushels worth $64 million. Every year we go to fields to looking for strep rust and put rust updates for send out rust updates and recommendations for growers to manage the disease. And we also identify risks from samples we collect from fields or sent by our collaborators. In last year, we identified 3 risks: PSTV 36, PSTV 37, and PSTV 39. This shows the frequency of these 3 risks occur in the US and in Idaho. We also test commercially growing varieties in experiment fields with inaculated and non-inaculated plots to determine the year loss. For example, last year, the susceptible check had 87% year loss, and the UI magic had over 44% year loss. Each year, we also evaluate Idaho wheat breeding lines for resistant to strep rust. These nurseries show and the number of lines in this nursery we tested last year. And we use this data to support in the breeding program to develop new resistant varieties. And this is a continual project. We will do similar experiments and in the following year. So first objective is to monitor occurrence, distribution, and the severity of strep rust, identify risks, and determine population changes of the strep rust pathogen. From these experiments, we also obtain the knowledge and data to make recommendations for growers to use fungicide or not use fungicide to manage the disease on a yearly basis. And the information and knowledge on strep rust epidemiology and pathogen population changes can be continually used to improve the disease control. The second objective is to screening wheat germplasm and breeding lines for resistant strep rust and identify new sources and genes for improved resistance to strep rust. The deliverable for this is new resistant varieties for growers to grow, and also the new genes markers developed in our program to support breeding programs to develop new varieties to achieve cost-effective and environmental-friendly control of the strep rust. Thank you for your attention, and thank you for your continued support of our strep rust research.